Okay, so just continuing with this question, we're up to B. So what mass of P2I4 forms one of our products? So we have to look at which of our reactants is a limiting reactant and use that mole amount to determine all the other proportions of the other reactants and how much of the product will be formed as well. The limiting reactant mole amount will determine all other values. So we're going to be using that value to figure out our unknowns. So the first question here, P24I4, so this is our unknown in this case. This is what we want to know something about. And so the iodide, we know that we have 0.0118 mole being used, and this is the limiting reactant determining how much P4O6 reacts, and therefore how much product we yield. So what amount mole P2I4 forms? Take our unknown coefficient, which is 4, and take our known coefficient, which is 8, multiply by our known value. So this is just going to be half times that value there, which is 0.0059. And the question's asking me for this value in grams, so we just multiply that mole value by its molar mass, so 0.0059 times the molar mass of P2I4, which is 569.6. And so the gram amount that will be formed is 3.36. Okay, so then the next question is quite similar. It's asking for the mass of P4O10. So that's our other product. So we do exactly the same thing, P4O10. So this is our unknown now. So 3 over our known, which is 8, multiplied by this known value, 0.0118, and that's going to give us a value of 0.004425, and that's the mole amount. So how much that is in grams is 0.004425 times its molar mass. So 284 is 1.2567 grams. So that's the answer to that one. And so then question D is asking me what the total mass of my products is. Total mass of products. So we've got 1 gram value here, P2I4, that was one of our products. This is our second product, so it's just going to be the total of these two, which is 4.61 grams. Okay. And the question says, hint, compare this with the mass of the reactants. So you might be thinking, right, well, given the principle of the conservation of mass, we've got 4.40 plus 3. So this is the gram value of my reactants. And so I'm saying that the gram value of the total gram value of my product is 4.16. Okay, does that look like the conservation of mass? Reactants, products? Doesn't look like it, does it? So what is going on here? Why is this smaller? Well, we have to think about there is another gram value that is hanging around that hasn't formed part of my products. So what would that value be? That is that gram value that was in excess. So there was 2.77 grams of my P4O6, which was in excess, and it didn't actually contribute to forming any part of my products. But it's still there, okay? And so when I add that to the product yield, 2.77 plus 4.16, I get a value of 7.38. And so just due to rounding errors, it's not exactly the same, but that is an indication that we do maintain a conservation of mass with my gram values here. So the question was just asking the total gram value of my products, which is this, so that's correct. But you may have thought that was not quite right because your total reactant gram value is 7.4, but you just have to bear in mind that you do have that 2.77 grams of P4O6, which is in excess hanging around. It didn't contribute to the yield of product that we calculated here. So that finishes off that question.